Now what is the expression for the generated voltage in a synchronous generator? So first we will discuss synchronous generator and then we will go to synchronous motor. Okay. So what will be the EMF per phase? It will be same as what we have been seeing for a transformer and an induction machine. So what is it? 4.44 F phi into N phase we will write. The number of turns per phase. So you can write the meaning of each of these terms. What is F here? F is frequency in hertz. The electrical power that is generated, what is the frequency of it, that we are talking about. Okay. So how can you get it? This you can get it as N into P by 120. Right. What is N here? Speed of the rotation of prime mover, or you can write rotor. P is the number of poles. Okay. So from here you can get the frequency in hertz, and phi is the magnetic flux per pole, and finally N phase is the number of turns per phase. Okay. So this is the general expression, but we have also discussed about the pitch factor and the distribution factor. Because of that, there is going to be a change in the expression for generated voltage. So what is that change? First is the pitch factor. So that means when you are using fractional windings, then something called as a pitch factor comes into picture. So this we represent as Kp. This is equal to 1 for full pitch windings, and it is less than 1 for fractional pitch windings. And next is the distribution factor. So this is represented by Kd. So this is given by the EMF generated in distributed winding divided by the EMF generated if concentrated winding was used. Okay. So similarly, pitch factor also you can write with a similar expression. What is the EMF generated for fractional pitch divided by the EMF generated for full pitch? That is why you get Kp is equal to 1 for full pitch. Okay. So the exact derivation of this is not required right now, but the final expression for the distribution factor, this you can write down. It is given by sine n beta by 2 divided by n times sine beta by 2. So what are each of these terms? Where n is the number of slots per pole per phase, and beta is the angular displacement between the slots. So that means if you are taking the stator like this and say this is the 3 windings in which we are placing the same phase. Okay. So now what is the value of n here? N will be equal to 3. Okay. Here n is equal to 3. Now what is beta? Beta is the angle between the adjacent slots. So this is given by beta. Okay. So now we can write the generated voltage including this pitch factor and the distribution factor. This is given by 4.44 Kp into Kd into F phi into N phase. This is generated voltage per phase. If you have to take the line voltage, in case of a delta winding it will be the same. Phase voltage will be equal to the line voltage. If it is a star connected winding, then you will have to multiply √3 to get the line voltage. Okay. So this is the expression for the generated voltage per phase in a synchronous generator.